1.
I'm ready! Woo!
Hi, Miss May. Good morning. So excited you're here on time. All right, hey class, we're doing 10.4 today, solving radical equations. No bell work today. Miss May thought she'd be nice to you all, and she convinced Mr. Deshane not to do the quiz today. So no quiz here. All right, solving radical equations is when an equation where the variable is inside of the square roots, and our main goal is to isolate the square root so that you can square both sides. So those are our key points. First example, solve the equation. We want to get the square root by itself. So we're going to subtract 7 to both sides. Square roots of x is equal to 9. We're going to then square both sides. For those of you that have forgotten, remember if we raise something to the second power, if it was in a square root, it cancels it, so you're left with x is equal to 81. That is our answer. Okay, we got to make sure it works, so you want to plug it back into your equation. Square root of 81 plus 7 is equal to 16. Square root of 81 is 9 because it's a pair, so 9 plus 7 is equal to 16. 16 equals 16, and it checks out. We're going to go ahead and give you a quick second so that you can go ahead and pause the video and start to practice. All right, welcome back, class. So you should have worked this out yourself. I'm going to add 5 to both sides to get a square root of x is equal to a positive 3. We're going to raise both sides to the second power to get x is equal to a 9. Again, this wasn't a negative 3, so we were looking at a positive 3 times a positive 3 to get a positive 9. I'm going to go ahead and plug it back into my original equation. Again, square root groups of 2 is 3 and 3. So we get 3 subtracting 5 to equal a negative 2. Negative 2 equals negative 2. So that checks out. All right. Our second type of problem that you will be seeing on this section is if both sides are already at a square root. We can't get the variable out of the square root without squaring both sides. So both of them are at a square root. That's step 1, square both sides. So we're going to raise both to the second power. Again, remember, something squared gets rid of the radical, so you're left with the inside, which is 5t subtracting 11 equals t plus 5. Our goal is to solve for t, so we're going to solve the remaining equation here. You can move whatever you want at this point. I'm going to go ahead and subtract t from this side. I do that to the other side of the equation. 5t subtracting 1t leaves me with 4t minus 11 to equal 5. I want to get t alone, so I'm going to move the negative 11 by adding it to both sides. 4t is equal to 16. Lastly, to get t by itself, I'm going to divide by 4 to get t is equal to 4. Now, up to this point, you're probably feeling pretty confident that your answer is correct, but again, you got to make sure on your homework that you guys are all checking your answer. So we're going to plug it back into our original equation. So square root of 5 times 4 minus 11 is equal to the square root of 4 plus 5. That gives us 20 subtracting 11 equals square root of 9, and 20 subtracting 11 leaves us with radical of 9. Now, you can obviously finish this. The square root of 9 is 3, but at this point, you just want to make sure that both sides are equal to one another. So you would not need to take this further. Again, if you wanted to, you could do 3 equals 3, and that would also check out. All right, class, if you were to flip to the back of the notes, the next one is going to be a practice problem for you. I will give you a pause again. Pause your screen. Pause. All right, class, welcome back. So you should have squared both sides to get rid of our square roots. We're left with 7x minus 4 is equal to 5x plus 10. Again, what I do, you may have done differently. solve however you want. I'm going to subtract 5x to both sides. 7 minus 5 leaves me with 2x minus 4 is equal to 10. Add 4 to both sides. That leaves me with 2x is equal to 14. And lastly, divide by 2 to get x is equal to 7. Again, for every problem, make sure you are plugging it back in. So when I plug it back into my equation, 7 times 7 minus 4 is equal to the square root of 5 times 7 plus 10. 7 and 7 make 49, subtracting 4 equals 35 plus 10. 49 minus 4 leaves us with the square root of 45 is equal to the other side with a square root of 45. At this point, you know that both sides are equal to one another, and so your answer is correct. You may be asking yourself, why have I needed to plug it always back in? Because everything we've done so far has worked. You're correct. Everything we have done so far is working. Moving into our next type of problem, we're going to have sometimes two answers. So we're going to be starting to talk about what an extraneous solution is. You're going to hear this concept a lot in Algebra 2. An extraneous solution is a number that appears to be an answer but does not make the equation true when it is plugged back in. So in our next example, we want to get rid of the square root. We can't do anything first, so we are going to square both sides. Raise it to the second power, raise it to the second power. Again, the left side is going to become n squared is equal to, the square root disappears because we're raising it to the second power to leave us with n plus 12. Again, super important part right here is please make sure you all change it into standard form, which means setting it equal to 0. So we are going to subtract n squared minus n is equal to 12, and subtract 12, n squared minus n minus 12 is equal to 0. All right, we are now dealing with a quadratic equation again. So this, we're going to use factoring if it can easily be factored, which it can be. If we're to do our big X, a times c is a negative 12. That makes a negative 1. Our two numbers that multiply to make a negative 12 and add to make a negative 1 will be a negative 4 and positive 3. Divide by our a value, which is a 1n. So we will be left with n minus 4, and n plus 3 is set equal to 0. Some of you were forgetting this in last chapter. Remember, they're both set equal to 0. You need to split them and set them each equal to 0. So up top, we're going to have n minus 4 is equal to 0, and n plus 3 is equal to 0. This one, we're going to add 4 to both sides. N equals a 4. And this one, subtract 3, so n equals a negative 3. Now, again, I've boxed in two answers, but we don't know if either of them work. So we're going to test both of them. Our equation was n is equal to a n plus 12, and n equals square root of n plus 12. I'll plug in 4 right here. We're going to have 4 equals 4 plus 12. 4 equals the square root of 16. We know that that checks out. So far, this solution works. Now, if we're to plug in this negative 3, we get negative 3 is equal to negative 3 plus 12, which is 9. I'm going to stop there. You should all remember that a square root does not equal a negative solution. So this is our no solution case. Okay, since it does not work, and I put no solution, that's not our answer, we're going to identify any extraneous solutions. So next to your answer here for Miss May and myself, you can write extraneous solutions. That is what your work should look like. We should see the answers, and we should see that they're both plugged in and show us which one works. That's a tough problem there. So Miss May, any questions or concerns or comments you want to add today for the class?
So is the negative answer always the extraneous one?
Not always. It does not always have to be, but most of the time it will work out that way. But it is best if we plug it back in. Okay, class, so there are now 2 practice problems for you all to attempt, so go ahead and pause your video. All right, welcome back, class. We just want to know that you're all doing your job at home to make sure that you're watching your videos. So on tonight's homework, Miss May and myself would like you at the top, when you submit it, to write hashtag Deshane May Algebros, right? That's going to be our hashtag moving forward. So support Deshane and May, right? So example 1, we are going to have subtracted 8 to both sides, which gives us a -6. We are going to square both sides to get 3y is equal to a, yes, positive 36, because -6 times -6 makes positive 36. We will divide both sides by 3 to get a y is equal to 12. Let's make sure it works, so plug it back in. So we get square root of 36 plus 8 is equal to 2. Square root of 36 is 6 plus 8 to equal 2, and I'm stopping there. There's no point of finishing this. We know that the solution does not work. So I scratch it out, and next to it I write that that was an extraneous solution. Okay? You may be asking yourself, well, there was no solution. You're correct. This is a no solution answer. There was a solution, but it was extraneous, which means it does not work. So our answer for this problem is no solution. That will happen from time to time. Example 2, square both sides. K squared is equal to a -15k. We will add 15k to both sides. Remember, class, we are always putting this in standard form, so k squared plus 15k is equal to 0. Miss May and myself selected this one because some of you have forgotten how these look. There is a greatest common factor of a k. So you are going to divide out a k. So k times k plus 15 will equal 0. Again, we are going to split these and set them both equal to 0. So right now, k equals 0 and k equals -15. Plugging them back in. Running out of room here, 0 equals the square root of -15 times 0. We know that that's 0 equals 0, so that checks out. Our next one is -15 equals a -15 times -15. Again, we know negatives do not equal square roots. But if you wanted to, that should come out to be 225. Which breaks to 15 and 15. So -15 does not equal +15. So again, to Miss May's question earlier, most of the time when we get a negative solution, when we're dealing with a square root only on one side, it's usually not going to work out from there. Okay? So this is going to, I'm going to switch the color so you can see. This is our extraneous solution. Okay, Miss May, comments or questions for the class?
Looks good. good to me.
All right, so again, class, that was the lesson. On your homework, you should have wrote hashtag Deshane May Algebros. Our first problems here, 1 through 6 on the front page, says solve the equation, check your solution. The back side says solve the equation, identify extraneous solutions. So that's 7 through 9. There is a word problem. Do your best on that one.
You can do it.
And then the last will be our cumulative review. So making sure that everything we teach you from before this break and continuing, that you continue on. And because we care so much about you guys, there is a answer key that follows. So as you're working through these things, if you are having issues, please email Miss May or myself, and we will create a couple videos or email you back for help. Thank you guys for listening. Again, we greatly appreciate you working hard through this time. We're here every day, Miss May. We're working hard for you guys, so please do your best and let us know if you have help. Miss May, thanks for coming to class. I hope you have a great time. Be safe out there.
Algebros rock!
Woo! Be safe and healthy. See you next time.